Hello, everyone. My name is Perez-Carreno, and welcome to the Web Talk Show. Today with us is Travis Malone. Welcome, Travis. How are you?
Hey, how are you? Good.
Good. I'm glad you're here. We're chatting off camera a moment ago, talking about quantum computing and AI. We want to continue the conversation with the camera because I think a lot of you are going to take away interesting golden nuggets from Travis's experience. A little brief intro here. Travis, what's your expertise? What do you do on a day-to-day basis? So listeners have an idea.
Sure. So I've been in cybersecurity for the past 6 years, and prior to that, I was in public cloud infrastructure as a service, platform as a service, all that good stuff. And my day to day currently is sort of taking what security and business leaders are kind of concerned about and translating that into how they can strategically go tackle those things using different security products. And primarily what I'm responsible for doing is helping them understand that the sort of traditional approach to security, where you buy a point product to solve this and you buy another product and another tool to solve this, and you try and make them all work together, is just kind of not going to work anymore. And to try and help them understand the sort of platform approach to addressing what's coming, right? So I have to constantly be on the forefront of what's happening.
Yes.
And that is an interesting place to be, because a lot of times, especially in the Fortune 100s, which are the customers that I work with every day, they're really just concerned about what happens this quarter, right? Or maybe 6 months from now. Sometimes they're interested in the 3 to 5 year conversation, but a lot of times it's, if the board just asked this question and we don't have a good answer for it, help us catch up, right? So it's kind of trying to balance those two things and helping CISOs and CIOs understand what options they have to secure their enterprise.
Nice. For the listeners, what is a CISO?
So a CISO typically reports into the CIO, and so the CIO being your chief information officer, and the CISO is the chief information security officer. So organizationally, the CISO is responsible for making sure that any information that is inside of the organization is protected and it doesn't leave. And I'm way oversimplifying it, but most CISOs mandates sort of fall into the SOC, or the Security Operations Center of an organization. A lot of times it also includes the network infrastructure services teams. So kind of taking those two sides of the business and making sure they're working together to protect the organization overall. That's typically their charter.
Nowadays, you were saying about how things are moving super fast, right? So are they having a harder time these days with a lot of people saying, ooh, ChatGPT looks fun, Gemini looks good, this Claude thing is working great? Is that becoming a headache for CISOs?
Oh my gosh. Yes. The short answer is yes. The long answer is they are sort of up against the challenge of making sure that the business can use AI to innovate and not standing in the way of that innovation, but also making sure that AI is not, that expanded attack surface is not further compromising their organization. And that is just complicated more and more every day, right? So like initially when generative AI came onto the scene, we sort of stopped talking about machine learning and moved into generative AI. And there was this sort of like conversation about, well, what is that attack surface? And it turns out that just like anything else, you can compromise a generative AI application, right? And then funny enough, some of the customers that I would talk to were like even less concerned about necessarily just using LLMs or building chatbots, right? And they were actually way more interested in exploring agentic AI. And so those two things almost happened one right after the other, pretty sequentially. And so that's where things got really weird, because with your standard like generative AI LLM chatbot type of an application, obviously there are things like prompt injection or like data leakage, or a lot of times what we talk about with customers is like data and model poisoning. So you've got attackers who have figured out how to kind of tamper with the training or the RAG data stores that these applications are built on, and get those models to return either like toxic content or content that has like links embedded in it that could be used for phishing or malware delivery or whatever the case may be. So those things were sort of like we were just discovering what those were, and then all of a sudden agents popped into the conversation, and the question became, well, what new risk does that pose? And so then it became a kind of a challenge of helping them understand, like, we're not necessarily worried about access to an application anymore. What you're doing with agents now is you're giving them you're giving them access to other applications, to your network. You're giving them autonomy to make decisions. So we're sort of not even thinking about like session tokens or the perimeter anymore. It's like what you need to secure. Now we're talking about like identity as the perimeter, right? And that becomes a really difficult concept for people to wrap their minds around, especially when they go, well, tell me about MCP and what you think about MCP. And when I turn around and tell them that I think, MCP is still a little under researched. I don't think it's a very mature protocol, to be honest with you. Then they kind of get all huffy and puffy, like, well, we've deployed, we've built all kinds of different applications with MCP, and what do you mean by that? So then we have to talk about things like goal hijacking, tool misuse, recursive loops, cascading hallucinations, right? All of those things sort of work together to make it harder for you to secure anything. And I've got like all kinds of examples, but overall, those are sort of the discussions we're having about AI with CISOs right now.
I don't think most people realize all this is happening behind the scenes. They just use the tools, they hear everyone is using them, and they're fantastic tools. We use them every day. I'm sure you use them every day as well. But when it comes to trying to secure something, it's this thin line between even good people, bad people kind of scenario, right? Like if you leave everything without any rules, then most people would be okay. But there will be some people that will step out of the lines and do something improper. Same here. Like you give this tool, it's amazing. If everyone was well intentioned, they're great because they just make it so easy to do everything. But it also, since it's so easy, now they can be tremendously misused at a scale that is just unprecedented.
Yes. And when you and I first kind of met and we're exchanging messages, you said something that it's kind of stuck with me, which is AI is such a great tool, but it's so misunderstood. And I think we're not even at the bottom of the very beginning of the bell curve for what AI is going to enable as a net positive for humanity. And so, yeah, you're 100% correct. I mean, it's one of those things that can be really, really great. But I think, unfortunately, and however misguided this might be, most businesses have begun to adopt it because other businesses were adopting it. And there's this sort of misconception that, well, if we build agents and we build them properly and give them the right guardrails, we can recognize all sorts of efficiencies, whether that is a reduction in headcount or, we can speed up time to resolution for different incidents or whatever it is.
Mm-hmm.
And the unfortunate reality is that can be true, but if you're not thinking about how this is going to impact your organization when other technologies get sort of thrown into the mix, then you're going to completely lose sight of what AI should be doing for you. And you're going to just run headfirst into shoving it into every product that you ever build without any real sort of benefit to an end user. And that's where, like you and I were kind of talking about earlier, this sort of like, I don't like to use the word singularity, so I'll use like the word convergence of AI and quantum computing. That's when those two things happen, I think everything's going to it's going to be really, really weird.
Where are we with quantum computing right now? Because I remember when I first heard of it many years ago, I was interested. I said, "Oh, we can't be that far." And then I looked into it a little more, and it just looked so far off because of the scale of it. So they were making these machines that sort of did it, but they were very abstract and they cost a lot and they didn't really do much of Like this example, like LLMs, right? LLMs first started, side note, and people were like, oh, they're amazing. They were amazing. But, I mean, not LLMs starting, but ChatGPT, like general usage. But then you would ask it a math problem and it would get it wrong,
Yeah.
right? And like same thing, now they've evolved and there's reason for that and we've talked about it on the show before. But the feel like at that point in time, going back in time when I learned about quantum computing, it was like, yeah, this huge thing, that's the most powerful thing, but it can not do like very basic stuff, right? And so I think there's a parallel there, and something very similar might happen, or it probably already happened. You can enlighten us there. That as the pace of progress in it grows, it suddenly the capabilities just expand. Not even exponentially. It's like it's probably even a different curve that we can even envision because we're talking about quantum space.
Yes. Yeah. And I think that's where a lot of people get thrown off, right? Is like they sort of assume that quantum computing is going to just like help us, solve all the world's problems at once. And that's not true, right? It's also not true that quantum computing is the same as traditional Turing computing. Like it's almost governed by the principles of physics, and the constructs of quantum computing are so different than traditional computing that people, I don't think, can really even grasp like how these machines are going to impact our daily lives. I also find it kind of interesting when I talk to anyone and I ask them like whether or not they understand what a qubit is. They don't, right? They have kind of an idea because people who are in our profession, they might understand what a bit or a byte is, and so they sort of take those two things and put them together, but they're often wrong about it. Number one. And then number two, when I kind of explain to them how quantum computing works and where we kind of are in terms of commercially viable quantum availability, they're always their eyes like open, because they just, even like some of the most tenured CISOs at the biggest companies in the world, they haven't quite wrapped their brains around this. I'll give you an example. So I don't know if you're aware that you can go right now to Amazon or AWS and you can purchase quantum computing power.
Yeah, I saw it, but I was very confused. Like,
Yes.
how?
So you can do the same at Azure, right? At AWS, the product's called Bracket. At Azure, I think it's called just Azure Quantum. And what you're essentially doing is you're purchasing these logical qubits, and you can call them through an SDK, basically. And the SDK will do things like spin up kind of a Lambda function and sometimes it'll spin up like a direct connect straight to the actual facility where the quantum availability is. And then what it'll do is it'll draw on the coherence of the qubit and then take that and apply the result it's able to garner from leveraging that coherence to traditional computing to then deliver a response. So it's not necessarily true quantum computing. It's almost like what we're calling the quantum advantage, right?
Yes.
It's basically saying like we're mixing quantum and traditional computing together and being able to leverage that to go do interesting things. So I'll give you some examples of how it's being used today, because you're laughing, but like this is real.
Wait. The reason I'm laughing is when I was in college, I went to the Hamburg High Performance Computing conference, the supercomputing conference, and I was there with people from CERN, from the Hadron Collider, and stuff like that. And they were talking. The people from CERN, the guy was like, "So we get stuff, we get data. He didn't say stuff. We get data from the collider, right? But there's so much data that we have to, like, there's not enough compute, there's not enough storage to process everything. So we have to filter out a lot of stuff. And so they were looking for partners and things to like be able to process a lot of that data. That just gets discarded, right? It's just like when the LM has to compact, right? It's like you have to discard a bunch. So when you're saying that, I'm thinking like, yeah, so the API call gets the data. How much of that does it actually get back that is available to then bring downstream, and how much of it is lost? Or is it like just this huge, like, how does all that work?
So there's that answer is not a straightforward answer, by the way. When we talk about quantum computing in general, there's sort of two concepts to think about when you think about qubits, right? So there's logical qubits and there's physical qubits. And then in order for a qubit to be considered logical, it can't be what is called a noisy qubit, right? And so when companies like AWS are selling logical qubits to people, what they're saying is this is a qubit that we believe is going to be delivered as a non-noisy qubit, and you're able to leverage that to do whatever you're trying to do, right? And so to answer your question, how much of the data that you sort of have the quantum compute run against comes back as legitimate or dropped, the answer is 100% of it comes back as legitimate, right? So that's where companies like EV car makers who are trying to crack the code on how to make like a better battery for their car, right? They're leveraging bracket biomed science companies, right? Who are trying to come up with all sorts of different scenarios for the drug they're testing, right? They're leveraging that technology right now because, to your point, they've got the empirical data. They need to then go run regressions against that data to determine what the outcomes would be. And just given the nature of quantum computing, we are enabling that data to be, you're probably familiar with like what used to be called elastic MapReduce in AWS, right? Where you sort of take the data, you break it out into different chunks, you sort of correlate the ones that make the most sense, and then you deliver what is probably the outcome that the user's looking for.
To make it faster.
Exactly. That's more or less the concept behind what quantum computing does, except that quantum computing will deliver you the actual answer. So that's kind of a roundabout way of saying that the data is going to come back 100% accurate.
Okay, so let's unpack this a little bit. What is a qubit in terms that any person listening could sort of maybe begin to grasp?
Sure. The way I've explained it to my father, who was in sort of building and maintenance facility roles his whole life. He knows how to build anything with his hands, but when it comes to computing, he's sort of lost. A traditional computer runs on bits, and a bit is like a light switch, right? So the light switch is either on or off. A qubit is almost like a coin that is spinning, right? So the coin is heads, tails on it, but if it's spinning, is it heads or tails, right? Well, it's neither heads nor tails, and it's also heads and tails kind of at the same time. So that's what a qubit is. A qubit is the sort of representation of a bit being in both 1 and 0 simultaneously. So when we talked about a qubit, right, we also have to talk about superposition, right? So superposition is exactly that concept of those qubits existing in multiple states at once. So if you're trying to figure something out, you've got all these different qubits, and those qubits that align to kind of come to the conclusion you're trying to come to, those qubits are, when they are aligned, they're in what is called superposition. And then there's the concept of entanglement, which is like if I had a coin and I gave you a coin and you decided to fly to Paris and those coins were sort of connected by magic, let's call it. If I were to flip my coin from heads to tails, your coin would flip to heads, right? And qubits in general will exist in states of superposition and states of entanglement. And sort of the way that the quantum computers come to the conclusion that you're asking them to drive to is through interference, right? So quantum computing literally runs on waveforms, and the waves for, let's call it a wrong answer, sort of automatically cancel each other out. And then the waves that are, that the probability exists that the right answer is within that waveform, those waveforms get amplified. And that is how quantum computers kind of come to the conclusions. So I'll pause there. Those are my best attempts at explaining the kind of concepts of how quantum computers work.
How do you get the machine to do something? So what is the quantum computer's input such that it can process something that you had in bits now in the quantum space? Like, what is that transformation? How does that, I mean, I don't know if we're getting too technical, but like in an abstract way, how does that transformation happen such that the machine can understand like the actual instructions that you're giving it and
Yeah.
what you're expecting?
Yeah. Great question. So when we talk about bracket, we'll just use that since that's the most viable form of using quantum computing right now. At its most raw form, what you're doing is you're feeding data into like photons and electrons.
Okay. Okay.
So it's kind of weird to wrap your head around, but there's a number of different modalities that quantum computers take, and depending on the modality that quantum computer uses, kind of determines whether or not the actual qubit and the interference that the qubit sort of takes on is going to be fast or slow. But if I were going to like write an app that was to take advantage of the current like bracket or Azure Quantum or something like that, it's like you kind of run hybrid jobs almost. So the first step is like you would use an EC2 instance in AWS to kind of prepare the data and the question you want to give the quantum computer. Then you would send that through the SDK or through the API that Bracket gives you. And then Bracket would use the QPUs, is what they call them, to kind of solve that impossibility, and then would feed it back to EC2. And then EC2, being a classical computer, would then take the result and then kind of optimize the result it got for the next question it poses, right? So it's like, I'm going to give you one math problem and you're going to solve it. And then you're going to tell me what the solution is. But then I have another problem based on the solution you've given me, and I'm going to feed it back to you, right? So yeah, I mean, that's kind of how it's done currently. So Bracket's got an SDK. And it's a Python SDK, and that just kind of based on the problem you're giving it, it will determine what type of modality Bracket should use in order to answer the question.
Wow.
Yeah.
That's amazing. Does it support, imagine, because of the problems that you're describing, does it support these huge data sets, or is there a memory limitation on it? How does that part work?
Yeah. So typically it's like with any other utility-based like cloud product, right? You're going to get billed on the amount of qubits that you want to use to run your calculation. And then there's a data ingest and egress component to it as well. But so you can choose the amount of qubits you want to use to solve the problem, and you'll pay per qubit per hour or whatever it is. And then based on the amount of data that you're sending it, you'll get metered on that as well and charged for that. So it's really up to you, right? There's not necessarily a limitation except for the amount of people who are in queue to use the slots available on those modalities.
We're back to mainframes.
For now, right? Because that is
for now. That
the
exploded
fundamental
really fast.
problem of quantum computing right now is like, I often have to help customers understand that we are not far away at all from commercially viable computers becoming cryptographically relevant, such that they will be able to break the traditional encryption that we know and use today for everything in a matter of hours, right? We're like 2 years away from that. The limitation right now is the availability of the amount of qubits required to run that computation. Because as you know, traditional encryption is basically just factorizing really large prime numbers. You know, our traditional computers, it would take, hundreds of thousands, sometimes millions of years to do that. I think the most recent study I saw, and this is kind of, if you've heard of the Advanced Quantum Technical Institute, Technical Institute, AQT for short, they actually put out a research paper this month that introduced a brand new algorithm called the JVG algorithm. And the JVG algorithm is basically a way for them to say, like, if I'm remembering the study correctly, it's basically an algorithm that's kind of restructuring the math that quantum computers use so that the processor on the quantum computer only handles like a smaller or like a leaner subtask, right? So it uses classical computing to do pre-processing and post-processing. And that allows the quantum computer to reduce its reliance on the amount of qubits it needs by 1,000%.
Wow.
Right. So they're saying instead of, I think it was like, 20 years is what a quantum computer, originally maybe 5 or 6 years ago might have been able to kind of break like an RSA key. They're talking about now, like they theorize they could do it in under 11 hours.
Wow.
And so
If
that's
you have 11 hours on the system,
if you have
like
11
that's
hours in the
the
system.
yeah.
Exactly.
Okay.
And if, yeah, if you want to pay for that, which,
Mm-hmm.
but make no mistake about it, like like nation states, lots of like, government backed research. There are also like scientific lab, like universities and stuff. They are 100% experimenting with this stuff and trying to figure out ways to reduce the reliance on the physical amount of qubits that you need and the amount of time it takes. So it's the actual algorithm itself, optimizing that algorithm to speed those things up exponentially. And when that happens, not only is our traditional form of sort of encryption and cryptography, not only is that going to break, but like we were kind of talking about earlier, we're going to see quantum computing be leveraged to speed up artificial intelligence. And that is where things get really hairy.
Jeez. The way the computer evolved was so interesting, right? When in the first calculators, computers started, and then when we got to mainframes, and they had the same issue, right? Access. Only the top universities or top research institutions had access, and so, but at the same time, yeah, like you were saying, specific maybe countries, nation states, etc. Certain organizations might build their own, steal their own, whatever,
Yeah.
to try to get access to, I don't know, process more data to be able to do things. Eventually, we got to personal computers, which, by the way, here in San Antonio, DataPoint Corporation was very influential in the creation of that first processor for Intel. And if any of the listeners are here in town or are visiting San Antonio, you should definitely check out the San Antonio Museum of Science and Technology, because they have a historical collection, not the main new building where the gaming arena is, but there's another building that has a lot of that history of how the first computers started, how those first personal computers started happening actually here in town, which is a fact a lot of people don't know about.
Yeah, San
I
Antonio doesn't get enough credit, I don't think.
no. Well, it all gets lost. It's like, oh yeah, everything happened in California. It's not true.
Yeah, like a lot of people didn't realize the camera on the back of your phone,
Mm-hmm.
that was invented by a San Antonian.
Yes, good friend. May he rest in peace. David Monroe. He was the owner of the collection that I'm talking about in the San Antonio
Really?
um, Museum of Science and Technology. It's all his collection. He's even got an Enigma machine there. He really pushed. He had a lot of patents. He really pushed the envelope in what could be done for computing and for cameras and for imaging and for a lot of things. And like you said, a lot of that is not known, that our town has a lot going for it in the tech space, which is very interesting. I myself didn't know a lot until I met David, and it's amazing how technology, if you go and take a tour, like how technology evolved to a point that suddenly, in a very short span, like if you figure when Ada Lovelace and Alan Turing were just getting into the thing, how many years passed until we actually had personal computers? And then from that, like how many years until we had smartphones? And now we have like AI and glasses and like in
Yeah.
rings, and it's nuts. And so, yeah, the same thing will happen with quantum computing. And people don't realize this, but as you were explaining, like, I don't know if our listeners are grasping the fact that all encryption, most encryption that we use in our websites, in banking and all that, it's just based on public-private key exchange. And we trust that that key is hard to break, like you were explaining. So if this machine can suddenly break it in hours, then the whole thing comes tumbling down. So
Yeah.
you were saying before we got on the camera that like there's now this need of rotating keys more often and looking at the whole security scope differently. Is that accurate?
Oh my gosh. Yes. And I'll kind of tell you from the perspective of the governing bodies who give business and industry and security in general the guidance of, number one, what the government is telling organizations they need to do and they have to do and they must do, as well as just like the general sort of like be aware of this sort of thing. And I'll start by saying that one of the most recent attacks I've seen in the wild with AI was mind-boggling to me, because I had never even really thought about this. But in a traditional cyber attack, somebody will obviously get access to a network. Usually that's by like compromising your credential, right? That's like the number one way that happens. And then they will sort of find a way to install a way back in. So if they ever need to leave, they can always come back. So persistence, right? Once they've got the persistence, then they'll do what they call live off the land, which is they'll find ways to move laterally, understand the network topology, get access to further, downstream devices and machines and things like that, and go do whatever they're going to do, whether that's steal information or whether that's, destroy things. Like, it doesn't matter. The fact is that once they have their foothold, it's really hard to find out how to get them out. And you used to have to know how to write code to do stuff like that. But one of the attacks that I saw last month in the wild, the adversary was able to gain, they just phished somebody. They were able to get access to the network. And then once they were on a workstation, their persistence back was just an API call to a large language model. And they said, I have access to this machine now. What commands do I need to run in order to get lateral movement? And the LLM was like, here's the commands you need to run. But the attacker took it a step further, and they actually dropped a script that was quite obviously written with AI, just based on like the commenting and some of the constructs that the was used in the script. The script basically went. It was a way to talk back to an agent, and the agent was then able to download itself onto the workstation, and then the agent just did the lateral movement for the adversary. So,
That's ridiculous.
like, you don't even you don't even have to know technology anymore. If you could just get access to a network and start running those sorts of things, like it gets crazy. Now, where I think a lot of people are missing the convergence is when quantum computing is used to power adversaries like that, and those sorts of like agents that get installed into networks, humans will not be able to keep up anymore. There's just no way, right? So there's this concept that a lot of professionals are talking about right now called post-neural quantum threats. Right now, what we typically see with like malware is what we call polymorphic malware. So it's malware that gets onto a machine, and then it sort of will recode itself based on some of the things it sees in the environment to evade things like endpoint detection and response tools and stuff like that. Yeah, but take that and then give it, agentic capabilities and quantum speed. It no longer is just going to rewrite itself. It's going to completely transform what it is to the machine. And at that point, if you don't have any sort of defense, if you don't have a defense strategy that removes humans completely from the loop, you're toast. And so that's where, like I mentioned, those government mandates, that's where those are like headed right now, right? So a lot of what we're being told by entities like NIST and CISA, in fact, there was a national cybersecurity strategy and executive order that was issued by the Trump administration telling federal agencies to prepare for this now. And what they're saying is, go build a zero trust model that is completely autonomous and completely self-healing, right? And they give you like different levels of how to do that, right? So they say, number one, you need to be able to detect and have the visibility and the rapid alerting that you need inherently, like built into whatever that strategy is. That's level one. Level two is automatic remediation, right? You need humans on the loop, but you want as many responses as possible to be automated. And if the system or the agents that are kind of running this strategy see something that they've never seen before, then they need to obviously like be able to reach a human so the human can make the decision on how to proceed. But level three is where this executive order says that you need to go, and that is self-healing, autonomous optimization, humans out of the loop. And the crazy thing is I mentioned that we're 2 or 3 years away from that quantum commercially viable threat to kind of, hit AI. Most organizations haven't even gotten out of level one yet, right?
Yeah.
Most organizations don't even have the visibility that they need. They don't understand what they're trying to protect, and they really don't have a strategy for how they want to protect it. Because when we talk about things like zero trust, I'm sure you've probably heard of that framework.
Yes.
But DISA gave us what zero trust should be and what it should look like, but they didn't tell us how to get there. And so organizations had to figure it out themselves. And so lots of organizations are just now finishing the work of trying to figure out what that zero trust matrix should look like, and then how they're going to implement it. And if you can think about big behemoth corporations moving at the speed they typically move, which is at a snail's pace, like I don't know that they're going to get there by the time that this all happens 3 or 4 years from now. So yeah, it's a very exciting time in the industry right now.
Yeah, and then you need to watch Tron and all the classics to see like
Or Dune.
what
I don't know if are you a fan of
Dune.
Dune?
I am not. I haven't. I know people are gonna hate me for this, but no, I have not. I have not read Dune. I don't know. I think I started reading it, and we didn't meet eye to eye. Like I'm a big fan of all the Asimov stuff. I've read most of his like Foundation stuff, all the Foundation stuff, and related. And I like science fiction, like Ready Player One. But Dune, I don't know. Just wasn't the time. You know how books, you read them, sometimes it's just not the right moment to read it, and just so I'm gonna try again.
Yeah.
But tell me what
Well, I was just, but there's this kind of like I don't want to call it's an archetype, I'll say,
okay.
of people in the Dune universe called mentats, and mentats exist because the human race basically outlawed computers like hundreds of years prior to Dune happening, but because
Okay.
it was what happened was catastrophic when humans got really good with computers and artificial intelligence, things like that. And so humans said, okay, that's it. No more AI, no more computers. And so humans then had to then become the computers again. And this mentat archetypes they kind of follow the leaders and the rulers around, and the rulers go, I have a question about this specific issue. And the mentats know everything, right? And that's kind of how it used to be back in, I'm sure, medieval times. But
Right.
it's funny to think about things like that. Just
Yes.
how quickly this is happening.
And yeah, and some of them got a lot right. Like obviously you've got the scary side of HAL and machines making their own decision, especially at critical levels. There's this movie that I watched a few years back that is not, I don't think it's like an A movie or whatever, but I don't know why I watched it, but it was, I thought the premise was good. It's with this, what's his name? I don't remember the actor's name right now, but it's called I or something like that. Have you watched a movie called Eagle Eye? It's about this AI that it's supposed to be very smart, and it's attached to the military or whatever, and it determines, because it knows everything and it sees everything. Spoiler alert, if anyone wants to watch this movie, skip ahead. It sort of sees that humans are good, but then it starts seeing all the wars and all the footage and everything and all the discussions and what happens, etc. And then it overhears a conversation in the Oval Office or whatever, or in the war room, and they're talking about like, oh, this is this guy, and then that we want to take out, and then the computer gives them like, oh, but it's just a 60% chance that it's the guy, but there's going to be collateral damage, blah, blah, blah. I suggest a no go, right? And then the commander-in-chief or someone says like, no, just take them out or whatever. And so it starts realizing, and then comes to the conclusion that the way to fix everything is to get rid of the chain of command that is like poisoned, non-morale or whatever. And so it does this whole thing, and there's many stories like this one, but it just runs into act, like you're saying. It's super powerful and super fast, so it goes and it generates voice to tell people things, and like overrides things, and just puts this whole thing into plan and into action such that everything aligns for this attack that nobody knows about. And then they pins it on someone else, like he sends weapons to someone's door, like so they arrest that person. And it's a fun movie. But it's like if you step back and like analyze it, like even if you've been playing with these agents recently, they sometimes make mistakes based on fallacies, right? Or a misunderstanding of how humans work. And yes, we make a lot of mistakes ourselves and sometimes very bad decisions. But if you're telling it to be completely truthful or completely whatever, it's going to do that. And that could back
It cascades.
against you.
It cascades, because what a lot of organizations are doing right now is they're daisy chaining these agents together. So you've got one agent that writes the code, you've got the other agent that links the code, then you've got the other agent that runs the regression tests against the code, and then you've got the other agent that pushes it into the UAT, and that, like, each agent's using maybe a different model, or it's trained on different data, and like if one of those models gets poisoned, for instance, what happens then when it gets sort of caught in this loop of wrong information or writing bad code or like injecting malicious payloads into that code, and then it passes that information on to another agent? Now that agent's model and memory starts to get poisoned, but then it gets stuck because it can't verify the code, it doesn't recognize the code, right? And so now everything downstream is stuck. And so it's like, yes, like not only are these things black boxes, but if we give full autonomy to them, we could end up shooting ourselves in the foot and finding ourselves in a real bind. It's again, finding that balance between helping folks understand what the risks are, but also helping them like look forward enough to be able to enable innovation for the business, but also to protect from what's coming. That's like the hardest part of a CISO's job, and the hardest part of my job is communicating it all. Because then what most people will ask me is like, how do we, if we're going to build this autonomous, self-healing, like closed loop security stack, where do we start? And the honest answer is like there is no purpose built like runtime for this stuff. Obviously with like agents or LLMs, like people are using Python as kind of the lingua franca of of how to deploy those things. Like I think like LangChain, LangGraph, Crew AI, all that stuff is Python based. But then you've got like actual policy enforcement, and most providers are giving people Terraform to do that. Or there's Open Policy Agent, which is kind of I think the closest thing to an industry standard for like machine readable policy. But then you get into like the orchestration or mediation piece of things, and lots of shops are using like Kubernetes native pipeline orchestration, so like Argo or Tecton. But then now we're talking about identity as the perimeter, and like more and more professionals in the identity space, when they look at SPIF or Spire, they're turning to Rust. And so you've got like all of these sort of different competing technologies that you're trying to use to piece together other competing technologies, and it just is we haven't as an industry, we haven't standardized on anything yet. And I think if there is a company out there that can purpose build that sort of autonomous security runtime, they're going to own the market share, and they're going to be very rich people. But it's just not there yet, and that's just sort of the next challenge that most people have, is like they know quantum's coming, so they have to migrate all their crypto from the old standards to the new standards, but then they've got to outfit all of their applications to be agile. And then at the same time, right, they've got to put these guardrails in place for AI, but then they also have to build this overarching framework for it all that is responsible for itself, and there's no standard way to do it. And so if we don't hurry up and figure that out, we are in for some wild times.
Especially since while there might be some rules here for certain things and what you can and cannot do, like you were talking about hacking with LLMs, etc. Full disclaimer, you should not hack. It's illegal, right? Unless you're doing it for pen testing or that's your job, right? But yes, if you go to a regular LLM like ChatGPT, Claude, etc., and you try something like that, it will tell you, oh, sorry, I cannot help you with that because it's like they have guardrails on it. However, as the Chinese recently showed us, they can get around that if they convince the LLM enough that it's actually like an educational kind of thing, and so they can still be worked around. And by the way, if you're interested in this, have you heard about Gandalf, the tool?
Yes.
There's a little training thing where anyone can go in, and it's from this security company, but you can sort of see how you fool an LLM, and it starts by baby steps, and it sort of guides you to see how people can extract information from LLMs sort of as a learning experience so that you can learn to see if you can beat the wizard or whatever. So I thought it was really fun because also it opens your eyes into where maybe I have to protect my LLMs and my endpoints and all that, right?
Yeah. I mean, the last thing you want to do is, if you're recently on the internet, there was like a meme that went around where somebody went onto the Chipotle website and they were asking Chipotle's chatbot how to write Python. And it was telling them, right? And then at the end, it was like, do you still want to order a burrito? Like, the last thing you want as an organization is to have a chatbot and people are like, tell me how to make a bomb or something like that.
Yes.
And all of a sudden it gives them that information. That's a big deal. But that's increasingly what attackers are trying to do, for sure.
Mm-hmm.
And then once they've done that, and now the model is regurgitating that information, well, now anybody using it is getting this toxic content or this poisoned content, and that's where everything starts to break down. So, yeah, we are in a very weird time right now, and I think at the end of the day, what most people should be doing is sort of being definitive in their decisions, right? Like, pick something to get the visibility you need. That's number one. And if you have trouble with that, there are all kinds of people out there that can help you do it, but you got to make that decision so you can move on to now, okay, how do we then go build the policy we need to secure all of these things ubiquitously? And then once you've got that in place, then you can start building your autonomous security fabric. But until you make that first step, you're going to be stuck. So,
yeah, I agree. There's so much we don't know about all this that even the people who do know are like, I don't know. There's this guy, what's his name? He's Nate B. Jones, is it? He does a bunch of videos. Yeah, no, not B. Nate B. Jones. He also, but no, there's another guy. I forgot his name. He does a lot of hardware stuff and Linux and Unix, and then also some hacking and some like server management and home lab and a bunch of videos. But he's really good at how he does. He's done it for many years. He recently released a video where he's like, this is gonna be a different video. I'm here in Japan. I just want to tell like what I'm feeling, how I'm feeling about the whole thing, blah blah. And he's like, I'm feeling the same thing. I'm getting overwhelmed. Like there's so many things happening so fast that we're all trying to play catch up, but at the same time we're missing out on other things that might be more important and stuff like that. Like speaking of like OpenClaw and everything that's coming out, and you just want to build stuff because you can, and you're gonna be left behind, right? But then he says, like, I'm gonna record more videos now of me actually just sharing what I'm learning, because in all this AI stuff, yeah, I know some stuff, but he's like, I'm gonna be humble and just like, I don't know a bunch of stuff because it's so moving so fast. We don't, like, nobody knows all this stuff. So I'm just gonna tell it as it is and not hype it as much, because that's how I'm feeling now. And I thought that was really good, because I think many of us in the industry are like, yeah, you could be an expert in security and software and engineering and whatever the field might be, and get better every day. But when it comes to all these things that are just every few hours something new comes out, there's not one expert out there. It's just not possible. And there's so much happening that it's just unknown. So yeah, I think it's very fun. I have a lot of fun with these tools all the time, and I think we can all just be mindful of how we're using them and what we could put in danger if we like expose certain tools or connect it to certain tools. So that's just what I think. But what before we go, what would you recommend to anyone who's just dabbling, like starting using these tools, maybe for a business, in terms of your expertise? What would you recommend to them so that they can not slow down their progress, but rather embrace all this that's out there, but at the same time do it with a certain care to be safe?
yeah, there's a number of things. Primarily, what you want to make sure you're doing is finding a way to give your users, and I'm speaking purely from the perspective of like an organization, like even a small to medium business, right? Find a way to give those users access to these tools, prevent them from, like, protect them from themselves, right? A lot of what I've helped customers do up to this point is put policy in place that will, for instance, allow developers to access Claude Code, will allow them to upload information into Claude Code. But if that information has intellectual property or PII or anything like that, block it, right? So apply some DLP controls there. And then also say, look, you can't download anything from cloud, right? So like maybe you can download a Python file, or maybe you can download an XML file, but you can't download a zip file, and you can't download a DLL file. You can't download anything like that, right? So put those guardrails in place, and then determine like which one of those SaaS applications, for instance, like Claude and ChatGPT, and those are all delivered through like a SaaS vehicle. But there's also things like Grammarly and Eureka and these things that you can install an extension into your browser and helps you figure out which one of those applications you can tolerate and that you're okay with. And then anything else, like just block it. Like, you know what I mean? So that's kind of the first one. The second one is when you're building agents, right? You or even just enterprise AI app like LLM apps, you always want to start with the code you're writing. An example that I'll give is there was a recent attack that was just identified where attackers are basically spinning up Squarespace websites that look like the Claude website, and they're using SEO campaigns to boost those websites to the top of search results. So users who are looking for like the VS Code plugin or something for Claude, like they go to these websites and they download the what they think is the plugin, and it's a compromised plugin, right? You have to start there, right? You have to make sure that everything you're building is being built with tools that are official, that have been sanctioned by your organization, and that are sort of actually lending itself to making sure that whatever code you're pushing is safe code. And then from there, anything else that you implement, make sure there's a purpose behind it, right? Like if I don't want my senior engineers reviewing code all the time, hey, that's cool. That's totally fine. But when you offload that to AI, don't offload the sort of like pull request approval process. Like, make sure a human actually has to see what the agent did and see what the agent caught. And if there's anything that doesn't look right, go verify it. Just make sure that you still keep the human in the loop currently, because to your point, like these systems are still black boxes, and we don't know what we don't know. We don't know what's going to happen with them. So you don't want to rip the human all the way out, but make sure you're purposely including the human and offloading any of the rote work that you can do. And then I would say probably the last thing is, make sure that you're upgrading your certs, make sure you're hardening your VPN tunnels, make sure you're doing all the things to protect yourself from quantum threats. Because like right now, what's happening is these attackers are exfiltrating this information that is encrypted, and then they're going to use quantum computers to decrypt it all later. So any information you lose now will unfortunately pay dividends, negative dividends in the future. So, just make sure that you're taking steps now to protect yourself from those threats. And I think if you do those things, you're doing everything you can right now. And as we learn more, obviously there will be more things that we can work on, but don't try and go boil the ocean. Start there and work your way towards the golden gates.
Amazing. That was super good advice, Travis. Thank you so much for coming on the show. And it'll be cool if we could talk again about more of this, because there's so much to talk about. I think people will really enjoy this particular episode. Thanks, everyone. And if you haven't liked and subscribed to the show, please do so with Spotify, YouTube, and Apple Podcasts. And thanks again, Travis, for coming along. And we'll see you in the next one.
Thanks for having me.